Hello, we start new video lesson about clusterization and clustering conversion. This lesson I'll show you how it does work in some REST-2D software, but it's working the same way in other softwares. Okay, let's start. I'll take my very simple example. And we will check how it's work. So, for example, the beginning, I'll start with typical inversion. Okay. To see model, I can get what clustering does mean. We used to resolve for very smooth, sometimes not very smooth models, like it here. And distribution of parameter is also smooth enough. So clustering, idea of clustering to have piecewise targets and with minimum number of it. For example, I'll put this model to the buffer and choose clusterization inversion. It's situated in joint inversion options. It's actually not joint inversion, but has the same settings. So I put it right here. And there is two different ways to start clusterization. If we already have model, we can start clusterization from current model. Or we also can start from half space to check how it's work. Let's see. Oh, sorry. There is options for special options for clusterizations. Should be smoothness constraint inversion or rich Marquardt inversion. So I'll choose this one, and also to tune power of this target of clusterization, we should choose this factor, but I'll left it to 1, so I think it's maybe okay for this model. So we shouldn't minimize smoothness because smoothness has opposite directions to clusterization, and we can see what happening here. So we have more contrast boundaries and piecewise host. And it will be continued process to make less anomalies in this section and to have very homogeneous targets. Okay, here we have C RMS. It's quite small for this example. I'll put this model to buffer. And now I'll start with half space. Because sensitivity of this part is very low, we can see different images after inversion. And a little problem of such clusterization is the upper layer. So I make it free, and you can see it's very heterogeneous. Okay, I think this is enough. I like first model more, but we can try to start again, but with another pushing factor to see if we make it bigger. We have not so much, usually not so much targets section. It's try to do all model more homogeneous. Okay. And for example, now we can start from this model and trying to use required inversion. So here is very sharp border, and here is approximately homogeneous media. So what we have? One cluster, two cluster, three cluster. Okay, and now let's compare all models we got. They should be pretty different in lower part. Yeah, I like this one much more. So maybe it's a good idea to start with normal inversion and do clusterization after. So, and this is not all. We have new options for clusterization. It's maybe not so useful when you have a single method, but for joint inversion result, you can find uh, joint common clusters. It's kind of factor analysis. So let me take my first model. And now here we have a cluster options. So we can use this, but it doesn't, it's a formal operation like a C-mean median clustering. So our RMS error after using this model will be not so good, of course. But we're not looking, we looking for the good contours of model targets, but not for RMS. And if we have a joint model, you can check these options on, and clustering will be applied to both models together. Now I can copy it. Yeah, and it's actually not so bad. Now let's check maybe another example. And here I will choose one again. It's too contrast, I suppose, so better to stop before. Maybe here. Okay. Oh, this is all about clustering in Zond softwares. Thank you very much for your attention, and bye-bye.